We're now ready to start looking at the EV3 sensors. So sensors give us the ability to collect information about the environment that our robots are in, and we can use the sensors in switch statements in order to create programs that are a little bit more intelligent. So this is going to allow us to create a robotic task or behavior that is going to be more sophisticated and perform more and more complicated tasks. Okay, so what I'm going to do is first go over the sensors that come with the EV3, kind of the standard sensors, and just kind of talk about the theory of how they work. And then what we'll do is we'll take a look at how we can use a sensor and actually trigger a switch statement or an if-then decision statement within the programming tool, and then we'll download it onto the EV3 tracker, and we'll see how they work. Okay, so to begin with, the ports come depending on what kit you buy. So you're gonna have this educational kit versus a retail kit, and the big difference is that one of the sensors is going to be different. One or two of the sensors are going to be different between the kits. But all the sensors connect to ports 1, 2, 3, and 4 on the brick. So you'll notice that the servo motors connect to ports A, B, C, and D, but all the sensors are going to connect to 1, 2, 3, and 4. So if you're having trouble with getting a sensor program running, one of the first things to check is to make sure that it's in one of the correct ports and that your programming construct actually is calling that port. So let's take a look at some of the basic sensors. So the first sensor that we're going to have is the touch sensor. The touch sensor has a little button on the end of it. It's kind of got a red cross on it. And if you press it in, it actually feels just like a button. And all it does is when it's pressed, it sends an asserted signal or a true signal into the program. And you can use the touch sensor to basically drive a decision. So remember that, the decisions in the programming construct, they're always based on true false. So you're asking a question of, is it true? If it is, do this. If it's false, do something else. And so a touch sensor would be an example of when it's not pressed, it's false, and when it's pressed, it's true. So you just basically feed that information into a decision, and you can kind of direct the way that the program flows. Okay. Now, a touch sensor is really useful for doing things like, number one, you can use it as a start-stop button, and that's what we'll do as an example. But you can also use it as a bumper, so you can attach, you'll see that you can insert an axle into the actual button itself, and you can create a little bumper on there so that when you run into objects, it'll trigger a true, and you'll be able to direct your program accordingly. The next sensor is the gyro sensor, and you'll notice this is unique to the EV3. It's going to actually give you the ability to measure instantaneous and accumulated angles. And so you can see that it's the gyro sensor because it's got the little arrows on it. And this is very powerful when you talk about knowing whether your robot is moving uphill or downhill, or if it's spinning or spinning too fast. And you could also attach it to some sort of mechanical arm that the environment presses, and you can figure out how fast that arm is spinning. So that's the gyro sensor, and this only comes in the educational kit, so that's something very important. If you bought the retail kit, then you don't get the gyro sensor. Then the next one is a color sensor, and the color sensor is a really sophisticated sensor. It can actually detect color. It's not just light and dark, even though it can detect light intensity, but it has the ability to detect colors, and it does this by shining a variety of spectrum of light onto a surface, and then it measures what has returned. So you can imagine that if it shines red and red reflects, then it knows that the surface is red, otherwise red is not determined. So this is a pretty powerful sensor, because in addition to the normal things you would do with a light sensor, such as light intensity, so imagine a burglar alarm, that when a burglar comes into your home and flips on the light, then your robot detects that the lights have come on, and then it starts chasing them or something. But that would be an example of a very passive light sensor. You can also do, of course, a line follower where the sensor shines at the surface that the robot is on, and it will basically try to follow a contrast in colors. So imagine you'd put a piece of electrical tape on the ground on a white floor, and you could set up the sensor to determine when it's on the black line versus when it's on the white floor, and try to have a program that automatically stays on the line, so you can do that. And then you can also do, what's an intelligent line follower. So imagine that you have a color-coded line that's drawn all over your office or school, and depending on as it's following the line, what color it's at, it would then do different tasks. So maybe when you go into one particular room, the line turns to red, and the robot would know that it's on the red, and so it knows it's in this particular room, and it will do certain different things that when it goes to the next room and it's blue, so then it does something different in the next one. So that would be an intelligent line follower. And let's see, then we also have the ultrasonic sensor, and this only comes in the educational kit. And an ultrasonic sensor is it's a sound sensor, but the frequency is above what the human ear can hear. So it's basically, it transmits a sound pulse that's above 20 kilohertz, so we can't hear it, but it can hear it. So this is the one that kind of looks like two little eyes, and so one of the eyes is transmitting and one of the eyes is receiving the ultrasonic pulse. And what it does is it detects objects. And it does this by, when it transmits the pulse, it measures how long it takes for the pulse to return. And then since it knows the speed of sound, it can say, well, that took 2 round trips, or 2 trips to the object. So it's a full round trip. So it divides it by 2 and says, okay, now I can calculate the distance to the object using distance equals rate times time. So this is a pretty interesting sensor. It allows you to create a program which can respond to objects in the way. Okay, so then you also have an IR sensor. So this one looks very similar to the ultrasonic sensor. It only comes in the retail kit. And an IR sensor is a little bit different than it works in the same theory of operation, where it can measure distances and it can detect objects by sending a pulse and then measuring the round trip time. But the IR is electromagnetic energy, so it uses the speed of sound, or the speed of light, in its calculations. Now the IR is a little bit more it gives you a little bit more capability, because the IR kind of can expand in a variety of different, well, it's just a little bit, it's the same technology that's in like a remote control or your TV. So you can actually have a beacon, an IR beacon, that you could potentially follow. And so you could actually have this thing to be a little bit more intelligent in terms of where it's going. But its primary use is really, detecting objects and measuring how far away they are. Now, I said that there's a remote beacon. There's a remote control that comes in the retail kit, which actually will send control signals to the IR sensor, and so you can control this just like a remote control car. And you can also leave it as a beacon. So imagine that you hide it somewhere and the robot tries to find it in a scavenger hunt, or imagine that it sets the base point for all operations. So you set the remote down, it sends out a beacon, and then the robot moves around it accordingly and only gets so far away. So that's the IR sensor. Okay, so those are the primary sensors, and just, depending on the kit you buy, you open it up and you're going to see, you're either going to have the IR sensor or you're going to have the ultrasonic sensor. But you can do the same exact tasks with it. We're going to use it to detect objects when they're a certain proximity to the robot and make decisions. And they're going to work functionally the same way. Okay, so now at this point, let's take a look at how we could actually use a sensor in a program. So recall that a sensor is going to give us information about the environment, and it's going to provide back something such as a true-false. So at this point, why don't we use the touch sensor to be a start-stop button, and let's take a look at how we can control the tracker using that. Okay, so go ahead and start up your Lego Mindstorms EV3 software, and you come to this screen right here. And then what I'm going to do is I'm going to come up and I'm going to create a new project. And at this point, you can see that I have my my tracker here, and I've already powered it on. And I'm going to take the touch sensor. So the touch sensor is the one that has the little red button on it, and I'm just going to plug it into port number 1 just for this example. And what I want to do is I just want to make a program that when I press it, it'll move forward just a tiny bit. And I'm going to say tiny bit because I'm going to leave the cable plugged in to make it go a little faster. So I'm just going to go 1 rotation when we do it. So how do we do this? Well, we are going to use a decision construct. So we come down here under flow control, and you're going to see a switch. So a switch is the term used to describe how the Lego Mindstorm software handles decisions. So if I come down here, I'm going to take a look at how this works, and basically it shows you graphically two paths that the switch can take, that the decision can take. So I'm going to first set up what it's looking at. So the first thing that I want to do is I want to click on this little icon right here as part of the switch and tell it which sensor we're using. So this one is already set up to the touch sensor, and you can say compare the state. And what that means is you're comparing whether it's been pressed or not pressed. So I'm just going to leave it as that, and let's compare state. And what this means is that when it goes through this path right here, that means that the button has been pressed. It will take this path when the button has not been pressed. So what I want to do is I want to insert a move command or move action into the path when I press it. And I want to just move forward really just like one rotation. So I go down into my action tab and I drag up a move block, and what I have here is I have 75% on the B and C motors, which is what we have connected. We want it to go for one rotation, and then let's just have it stop. So just by default. Now at this point, this program, if I ran it and I didn't press the button, it would immediately do one of these paths and end. So if I didn't have the button down, it would go through this path, which is nothing. I don't want to do anything. So it would go through here and then just end. So I would download it and nothing would happen. So as an example of that, why don't I just hit download? So it's down there. And notice that it's not responding. And the reason is that it's already gone through this path right here and ended the program. I can do this again and see that my program is working if I press and hold this and hit download and run. In this case, it saw it. So it was said, okay, at startup, I went through this path right here immediately, and then I ended the program. So if you wanted to make a program that would continually run so that I could actually sit there and hit the button over and over, and every time I pressed it, it moved, I need to enter a loop construct. So let's go back to flow control, and I'm going to grab a loop now, and I'm going to put this at the beginning of my program, and now I want to drag my switch into it. So I'm going to go ahead and drag my switch or my decision statement in, and now I have this. I want to set the loop to go forever, which is unlimited, so I leave it as is. And now let's take a look at how this works. So go ahead and download, and now watch, I go. Every time I press it, it goes. Every time I press it, it goes. Okay, so now it's continually in that loop. Continually in that loop. And you can actually see when the cable's connected, the software shows you which loop it's in. So watch right here at this green and watch what happens when I hit it. Notice that it kind of highlights, and then you'll notice that the loop is highlighting, showing that it's always running. And there's nothing in this box down here, so it doesn't show anything, but it does graphically show you what block the program is executing when I press this button. Okay, so that is how you do it. Now at this point, what we want to do is we want to add some sensors to the tracker so that we can start making decisions. And we came up with this, or I came up with this little design that's going to use the IR or the ultrasonic sensor, and it's also going to use the light sensor, and it's going to point the light sensor directly down, and it's going to point the IR sensor straight forward. So this will allow us to do things like track a line, or it'll allow us to detect an object. So you're going to be provided with some construction plans that I created, and I just did this. I built this up and then I took some pictures of it. So this is the end result, and what I do is you're going to build this little piece part right there. And so what I did is I just took a bunch of different pictures of it, different angles, and you can kind of see from all different angles how the thing goes together. And then when you get down to the end, I show you the exploded view, so I show you everything taken apart, and then I show you which pieces you're going to use. Big thing here though is connect the color sensor to port 1 and the IR to port 2. If you only have an ultrasonic sensor, then just connect that to port 2. They'll work the same way. But at this point, you're going to be able to add these sensors on there, and then going forward, what we can do is we can make some more intelligent decisions about what we're actually having our robot do? Okay, so at this point, what we're going to do is in this module, there's actually 4 sensor videos and some activities. And so what I did is I put a very small check on here representing that we're making our way through the sensors module, but it's going to take 4 of these little checks to actually complete this. So at this point, we kind of know what sensors are there. We know how to include them in a program, in a decision, and we know how to put that in a loop, and we know how to trigger motion. So we can actually now turn our attention to doing some pretty sophisticated tasks, and we'll kind of walk through these in the next set of videos.